This video is going to be part 2 of my review for the ARRIS CM2000 Brushless GoPro Gimbal. Here I have the completed gimbal installed to my X650 Pro frame. You'll see that in the top here I used 4 zip ties to secure it to the frame. These here are two 10mm load pipes with about 60mm of separation between them, and the 2 slots that are on the top plate of the gimbal worked perfectly for routing the zip ties through to secure it to the top plate here. Now the rubber dampers are pretty flexible. They do help get rid of a lot of the jello. They work quite well. But some of the more firm dampers might do a better job of isolating vibrations from the camera. However, for the most part they get the job done. And I haven't really experimented with any other kinds of dampers, so these have definitely worked better than anything else I've used before. Now the front here of the gimbal controller has 3 signal wires, and these 3 signal wires are what are used to manually control the pitch and roll of the gimbal. The blue wire, which is on the inside, is the common ground wire. The middle green wire is to control the manual roll of the gimbal, and the outer yellow wire is to manually control the pitch of the gimbal. Now, in my first part of my review, I noted that the top of the control board had a wire that was rerouted from the manual pitch pin to the microcontroller. And the reason for this is because the software that's used on this board is not actually intended to be used on this board. So therefore it requires different hardware in order to be able to manually control the pitch of the camera, and by modifying the board with that extra wire it will work with the software that is currently installed, and I'll get into that a little bit later with some more details. So this signal cable routes back to the receiver that I have mounted on my frame here. This is a FrSky receiver, and I only have the manual pitch control hooked up to the 8th channel with the common ground wire. The manual roll control I have disconnected. And let's see here, in the back of the gimbal, it may be difficult to see, but I have a JST plug to power it, which comes from the power distribution I have on my frame. The battery I'm using is a 3-cell battery, and I believe this board is made to support 2 or 3-cell batteries, and I would not recommend using it with 4-cell, so don't do it. Let's see. Overall, it's very well constructed. Mounts nice and securely to my frame. I believe these mounting holes here will work with a Phantom as well. The gimbal was well balanced when I received it. The pitch axis isn't ideally balanced, but there's really nothing more that can be done about that. If the camera was shifted upward a slight bit more, it would be better balanced, but you would also lose some of the travel. And the slots aren't long enough to be able to slide the GoPro up higher. So because of that, sometimes when the camera's tilted directly downwards, I'll see oscillations in the gimbal, and there could be a couple reasons for this. I haven't exactly determined what the problem is. My first thought is that perhaps since the balance isn't exact, if it slips, it'll begin to oscillate. And the intensity of the oscillations, of course, depends upon how well it's tuned or how poorly it's tuned. If it's not tuned properly, the oscillations will perhaps get worse and it'll become unstable. But if it's tuned properly, then there shouldn't be too much of an issue, as well as it's balanced as best as possible. And another thing I did to help avoid oscillations when it was pointed directly downwards is I limited the travel of the gimbal to only 85 degrees along that axis. That way, when I have it rotated all the way downwards from my transmitter, the gimbal, although it looks like it's pointing straight down, is actually only 85 degrees. and at 85 degrees I didn't notice any issues. Now that could have something to do with the control algorithms that they're using, but I'm not quite sure. So in short, if you limit the rotation to 85 degrees, it should help to eliminate those vibrations. And it's also important to have the right PID settings, or PID settings tuned. Now, a few things I want to mention about this board is that the control board it's using is the version 3 Martinez board. However, even though the version 3 Martinez board is intended to only be used with open source firmware, somehow Hobbywing was able to put the Simple BGC version 1.3 firmware on it. And the Simple BGC firmware is much better. However, it's a closed source firmware and it's not intended to run on this hardware, which is why it was modified to be able to work with the manual pitch control using that wire. Now, I don't know if they're going to continue using this software or not. The actual official Simple BGC controller is a $150 controller. And the way it works is the software and the bootloader for the controller have been modified such that it can only work on that controller. Or if the individual, say, that produces the board or sells the gimbal decides to, they can purchase the copyrights from the Simple BGC developers and then use the software. I don't believe that any copyrights were purchased for this, and the software that's currently running on my gimbal that came with it when it was shipped, I believe to be a pirated version of the firmware. And therefore, if for some reason you decide to reflash this, or the control software is damaged, say, then you're out of luck because there is no way to revert back to the original firmware. Now, I spoke to Nancy about this from Hobbywing, and she said that they ordered many of these controllers in bulk and they were unaware of the fact that the software on it was pirated. They also told me that there will be a new software coming out with a new user interface, and it'll be rebranded as CM2000 software. And I do not know when that software is coming out, but it was a bit disappointing to me to see that they were sending out controllers with this software, not releasing firmware updates for customers that paid for the products and so forth. But fortunately, everything seems to be working. I was able to test it with the Martinez firmware, but I would not advise to do so. It's very easy to mess something up in the process, and from what I've read and experienced, the software that comes on this gimbal controller, or at least what I received, is the best software, with the exception of the newest version of Simple BGC, version 2.0 beta, with many new features. However, because this is not a valid copy of that software and it's not a supported flight controller, the software cannot be updated to version 2.0. Ideally, I would like to see Hobbywing put forth an effort to develop their own firmware or purchase the licenses from Simple BGC, or at the very least offer download links for firmware that is supported on this board so that customers can upgrade the board if necessary. And we'll see how that works out. But overall, quite satisfied with it. I'm going to go ahead and plug this into the computer real quick so I can just demonstrate some of the features in the user interface. The mini USB cable, which is not included with the board, plugs in right beside the signal wires to the front of the gimbal controller. Once you've plugged it in, you'll want to open up the user interface. And the user interface can be downloaded from the Simple BGC website, and it also should be saved to the CD that comes with the gimbal. Now, I'm going to pull this up here. First thing you'll do is you'll pull up the user interface, and this might be difficult to see, so I'll explain what I'm doing. But once you pull up the user interface, along the left side you'll see a list of COM ports. You'll want to select which COM port you have connected through the gimbal, and once the blocks turn green you should see a sensor readout on the graph on the bottom screen here. When you press the read button, you should see the firmware version listed in the top left corner, which is version 1.3, and you will also see a list of the PID settings, power settings, RC settings, and so on. In the graph down below, you can change the scale by adjusting the number in the top right corner, and you can also choose which traces to show in the graph. This can be useful for tuning things. For instance, you can isolate the pitch axis of the gyro, and from there you can determine how smooth it rotates by looking at the angular velocity of the gimbal as it rotates. Now, as far as the settings are concerned, the default settings that came shipped with my controller worked quite well, but I did make some changes to them. As I said, really the only issue I had was that when it's pitched downwards at 90 degrees, I had some oscillation problems, so I've been trying to work those out, and I've seemed to achieve a much better result than originally. And I did that by changing some of the PID settings and increasing the power, and also modifying it so that the limit was 85 degrees. Now, the one thing that I did notice is that when I plugged this in and looked at the original settings, the number of poles for each motor, I believe, was 14 and 16. Now, there's an option to automatically adjust and look for the number of poles on the motor by performing a little adjustment algorithm, but I went ahead and I looked at the motors, and it appears that each motor has 12 poles on it. So I manually input those into the interface here, and I selected to invert the pitch motor. After that, it should be able to move properly with the correct settings. Now, for the PID and power settings, for roll I have a P setting of 26, and for pitch a P setting of 20. For I have a roll setting of 0.32, and for pitch I have an I setting of 0.30, and for D I have a roll setting of 10 with a pitch setting of 4, and for my power settings I have a roll setting of 90 with a pitch setting of 68. For the integral and derivative terms, the I and D terms, I would recommend using for I something in the around 0.3, and for D I found the best values to be 10 for roll and 4 for pitch. Any values other than 4 for pitch did not work well, but for the roll axis I was able to do a range of somewhere between 8 and 12, sometimes up to 14, but I found 10 to be a pretty good number to use. For the proportional settings, or the P term of roll and pitch, somewhere around 20 to 30 is probably a good number. If you choose to tune this yourself, I would recommend leaving the I and D settings alone and tuning the P settings and the power settings to best achieve the performance you want. If your gimbal is slipping and inducing oscillations, then those can be achieved by tuning the P setting and adjusting your power. If it's slipping too much, I would recommend increasing the power, but you have to be careful that you don't increase it so much that it begins to cause high frequency oscillations or the motors overheat. So for that, I have the power settings for roll somewhere between 80 and 90 is a good number, and for pitch somewhere between, say, 50 and 70 would probably work. Maybe different for your gimbal. Now, for the RC settings, this is where you will set the maximum travel for the gimbal. Since I am not using the manual control of the roll axis, I've zeroed all of those settings. For the pitch axis, I have it set up so that the camera can rotate from a forward-facing position directly downward. So when it's facing forward, the minimum RC angle is 0, and when it's pointed directly downward, the maximum RC angle is 85 degrees. And as I said, at 85 degrees I didn't experience oscillations as I would often with a 90-degree limit. Now for the low-pass filter speed setting, what this will do is it'll average the rotational speed, and with a low setting it should move quite fast, but with the high setting it will move very slowly. However, it will be a more smooth movement with less vibrations or twitching in between. There's also a checkbox to be able to alter the mode of manual control. Right now I have it unchecked, and with it unchecked, the angle of the camera is proportional to the value of that channel. So in other words, if I have my knob on my transmitter rotated all the way in the negative position, it goes to the minimum RC angle. If I have it rotate all the way to the maximum position, it goes to the maximum RC angle, and anywhere in between it'll hold an angle between those two limits. If you check the box, then that channel has to be at 0 in order for the camera to stay stationary. If you turn it in the positive direction, the camera will be able to rotate in the positive direction, and the more positive that value is, the faster it will rotate, until it hits whatever the maximum limit is, and then it will stop. For me, I found that unchecking the box and leaving it this way is the best for getting smooth camera shots and being able to control the gimbal and fly at the same time. Beneath that, you'll see the external flight controller gains. Now, because this software is not intended to be used with this controller, I do not believe that setting will work on this board, but it may be worth a try if somebody decides to mess around with the settings. Ideally, what that would allow you to do is, if you don't have enough channels on your controller, or if, say, you're using a CPPM controller with your flight controller, then you won't have enough channels to control this using the pitch and roll pins going to your receiver. So what you'll need to do is wire them to your gimbal controller that's built into your flight controller. Problem with that is the outputs from that are generally stabilized, so it would be redundant to use both the gimbal stabilization of your flight controller and the gimbal controller. So by adjusting those settings in the user interface, it allows you to properly adjust it to match the gains that are output from this controller, and use the outputs from the, say, NASA F1 and F2 ports to be able to manually control the gimbal. Now, the reason I say this may not work is because in the official board that's intended to be used with simple BGC, there are additional pins to this pitch and roll pins. Not only are there manual pitch and roll pins, but there are also flight controller pitch and roll pins. And I believe those pins are necessary to be able to use this setting in the interface, in the software. And since this is not that board, since this is the open source board, you do not have access to those pins. And really the last setting in here that I was going to talk about is the accelerometer calibration setting. I believe there's two ways to do this. There's the simple way, and then there's an alternative way that allows you to get a more precise measurement by rotating the camera to different angles and calibrating it. All the details about tuning and calibrating the accelerometer for this specific firmware can be found in the Simple BGC manual. However, the firmware that shipped with my board may change in the future. As I said, Hobbywing has told me that they will be releasing a new firmware for these controllers, and I don't know if this firmware is a modified version of Simple BGC, if it's their own firmware or what, but perhaps they will include a manual to describe how to use this software when they do choose to release it. I'll just demonstrate real quickly some of the settings I have in my radio here. So I'm going to disconnect this from the computer and remove the USB cable. Alright, now the radio I'm using has ER9X firmware installed to it, which is very convenient for programming advanced features or gimbal controls, camera controls, stuff like that. It's an open source software, and you can use it with the Turnigy 9X radios and perhaps other radios as well. But the radio I have here is a Turnigy 9X. Of course, it's been modified to have a FPV monitor and so on. Now, I have two knobs on the back corner of my radio here. The first one I have set to be the initial position of the camera. So with this switch here flipped backwards, that will be in the off state. And in the off state, it holds whatever the initial position is. So I can rotate the rear knob to set whatever angle I want the camera at. Say I want it at 0 degrees, that's where it'll stay. The secondary knob is for the final position of the camera. So if I flip this switch, it will travel from whatever the initial angle is to the final angle in a nice smooth movement to be able to get whatever camera shot I need. So when I do flip this switch, it should travel from 0 to 85 degrees, since I have the rear knob positioned all the way to negative and the forward knob positioned all the way to positive. So as you see, when I flip the switch, it slowly rotates down. Much like the low pass filter or the speed setting in the user interface with the gimbal controller, my radio also has a feature to be able to slow the movement of that channel. And so with that, I was able to set it so that it takes several seconds to rotate downwards. That way I can continue flying while the camera maneuvers itself and not have to worry about controlling multiple things at once. Now when I flip this switch back, it travels back to the initial position. And say I only want it to go down 45 degrees, I can adjust this knob so that it's at the center position, and when I flip the switch, instead of traveling all the way down, the camera will only travel halfway. So that's just how I have it set up to control from my radio. It's nice to be able to have those advanced camera features. Some other things that you can do, for example, is I have a setting on here to be able to hold my throttle at a certain percentage, and after that there's a safety switch I can select, which will from there, after it's enabled, allow me to control the camera using the left stick. So with the left stick I control the pitch of the camera and the rudder of the aircraft. So in other words, whatever I see in my FPV monitor can be moved proportional to this stick here. That's something that you'll definitely want to have altitude control on your flight controller for, because in this mode you have very little control over the throttle. I do have it set so that when this mode is enabled, the throttle is reassigned to the third knob on the back of the controller, and that third knob is only weighted to be plus or minus 10%, such that you can either have the aircraft maintain altitude or traveling upward or down very slowly, but that way you don't accidentally have it set to a number such as 0 or 100%, where once this mode is enabled the aircraft shoots off into the sky. That's definitely not something you want to do. And to help prevent that, it takes 2 switches on my radio to enable this feature, and in addition to that there's a 2-second delay between when the switch is flipped and the mode is activated. In the future I may put together a video on more advanced programming features in ER9X, how to be able to set up your radios like this and do some advanced camera maneuvers from ER9X. When I finally get around to doing that, I should have a video posted to YouTube, and maybe I'll write an article on my website about that. So just to conclude this video, overall I really like this gimbal. It's built well, the materials are nice, the motors have great bearings. I would say my biggest gripe would be with the control board. I don't like the fact that it has been modified and they're using pirated software. I think the software works great, but nowhere on their website do they have firmware updates, and it would seem to me that practically every other week now they're releasing some sort of update to this gimbal. I think it was only 2 weeks ago they completely redesigned this and released a version 2.0, and as of yesterday I'm now hearing that the board I have was the original version and they're already releasing a new version of the board. So as a paying customer, it disappoints me that a week after I purchased it they're already making changes to the gimbal to correct for problems in the original design. I feel as if right now, instead of being a version 2.0, this is more of a beta product that's still in development, but nevertheless it works quite well. The Hobbywing has been very good with their customer support. I've been communicating with Nancy about some of the issues I've been having with the software, and she's been very attentive to any problems I have. So I would say because of that I'm very happy with having purchased this. I know if, say, this was something I purchased from Hobby King or Good Luck Buy or practically any other foreign company, chances are I'd send them an email and never hear back. But Hobbywing has been very good with their customer support, and if you run into any problems, I'm sure they'd be very happy to help you out. But really, you know, that's the only major drawback that I see to this, is that they keep making changes and not updating customers who already purchased their gimbals with those changes. Just another example is on their website, I believe this motor here is a different motor. The pitch motor I received is a little bit heavier, but it also seems to perform quite well, and it probably has more torque than the motor they were previously using. However, there's other users who have received different motors, and it just makes me feel as if these things have been thrown together with spare parts. But it works very well. So I don't know what their reasoning is behind mixing and matching parts and making so many changes. But I can say I would much rather prefer that they do make improvements to the gimbal than put out a product that doesn't work and never provide support for it. So for that, I really do like this gimbal. If you're looking for a GoPro gimbal, I would recommend it. If you're hesitant, maybe wait a few weeks, see if the firmware issues get ironed out, and if what other people are saying about the gimbal. But for the most part, it works out of the box. There's some more tuning and stuff that you can do if you want to improve the performance of it. But it really is a pretty user-friendly installation. Everything comes already assembled. You just have to mount it to the aircraft, plug it in. If you want, you can change some of the settings, but it's not absolutely necessary, and it should work just fine. So I think that just about concludes this video. If you have any questions, you can leave a comment or email me through my website. There's also a support thread on RC groups where Nancy and some of the other HobbyWing staff have been answering questions, and they've been quite helpful with answering questions that people have. I'll be uploading some flight videos of this later on, hopefully by the end of the week or middle of next week. It's been quite windy here, so it's been difficult to find a good day to fly, but once I have those completed, I'll upload some videos. I'll probably also upload some clips showing the problem I was having with the pitch oscillations, just to demonstrate what was going on. But hopefully by now, or by the time I get my next flight, that'll be ironed out. If you liked the video, don't forget to subscribe. I'll be updating my website and the review for this with more information if I find more ideal settings for the gimbal. And thanks for watching.